Okay, so we are going to discuss now induced current. So what you're seeing there is trying to represent a magnet. Okay, so this is the North Pole and this is the South Pole. Remember, the direction of the magnetic field leaves the North Pole, so the line of the magnetic field. The convention tells us that the lines of the magnetic field leaves the North Pole, goes all around to the South Pole. So here where you see the North Pole, you see the lines going out like that, going up like this. Okay, and what I'm bringing here now is a loop with wires. No? The wire starts here, goes all around, and then leaves this way. Okay, so it's a wire. It could have current going through. Well, if I just hold this loop like this, well, there'll be no current. No, there is no potential difference. There is no current. If I hold it up there, again, no current. But as I go from up there into my magnet, then I will induce a current. I'm going from a scenario where the magnetic field in this loop is very weak, and I'm making this magnetic field stronger and stronger. Okay, so as I make this change, I will induce a current that wants to oppose this change. Okay, so I'm very weak, and the field going through this loop is getting stronger and stronger. I will induce a current that will create a field against that one. So how can I be against this change, this field that is getting stronger and stronger? How can I create a current to bring us closer to the initial scenario where the field was weak? Well, thumb gives the direction of the current. So you see that if I put a current like this, in other words, clockwise, and if I put a current like this, look at my four fingers. My four fingers are going into the page. So the magnet is coming out of my loop. My four fingers are going into, out, and into. I will make this field weaker. Okay, so initially I was weak. As I bring my loop, gets stronger and stronger. Okay, weak, bringing it becomes stronger and stronger. I want to oppose, so I put a magnetic field against that one to make it weak again. So that means I induce a current that is clockwise. Now let's do the opposite. Let me start here, where we have a lot of strong magnetic field going coming out, as you see, from our loop. Okay, so we have a very strong magnetic field coming out of our loop. I'm holding there is no current, but as I remove my loop, I'm making a change from very strong initially to weak. So very strong initially to weak. With this change, I'm going to induce a current again to oppose. If I'm going from strong to weak, I'm going to induce a current. See my thumb? I'm going to induce a current that is now counterclockwise, because this gives me field coming out. So if I'm going from weak, now we're starting here. Now we are going from strong to weak. If I induce this current, I bring the field back. Okay, so I'm always opposing my change. A lot of field getting weak and weaker, I induce my current to bring this field back. So that's the idea. I'm going to do everything else in a piece of paper. Let's see which one you prefer.